Hello. Let me share my screen in its entirety. Okay, can you see my screen? Alright. So this is a 5-hour study session, and we're gonna study NLP. So let's talk about the goal, what we're gonna study. So today we're gonna study Introduction to NLP, and so we have 3 sections. Section 1, Introduction to NLP, Basic NLP Techniques, and Vectorizing Data. And the challenge will be 5 hours of studies in one go. And we're going to study all of them. We're going to cover all of them. Plus, we're going to also take introductory reinforcement learning. It's very basic course, so this will be the goal. And then here is my way of learning. So this is kind of my philosophy. So to get anything, understand something, you gotta process it very well. So which means you take the information, then you associate it with the past experience. So that makes it meaningful. And then that leads to understanding the subject matter. And then you can generate whatever you want. You can solve the problems, you can understand, you can express it in your own way and into practicality. So yeah, this is what I mean. So what I mean by processing means we will draw diagrams, search a lot of searches, okay, to understand it and to make it concrete. So the timer will start now. So once we hit 5 hours, we're gonna stop and continue. So let's set 5-hour alarm. So we're gonna cover 2 chapters today. So I have these resources right now, Google, and Google, this icon, I use this drawing website, and then I have flashcard and the things I want to study. This is the resources I have, and also I will take notes here. Okay, so let's begin. So I took some notes previously. So here are the things that I didn't understand. There are terms. I don't understand what data vectorization is and what are the techniques. What do we mean generate, understand, and process? And these are junkies, and I will fill them here. Okay, I put some jargon terminologies right here. So what is view modes? So NLP is natural language processing, which means a machine. So you teach a machine to generate a human in a way of interaction. So you, as a person, interact with the machines. For example, as I am right now, I'm interacting with a computer with this graphics interface, and this is kind of natural. It's not natural, so I click the buttons and everything. But when it comes to natural language processing, human beings, interact with natural Martians, kind of level up the interaction one more steps, because you are interacting with things that can understand your language and predict an answer based on your inputs. So they can process it and can generate an output. So whenever I'm interacting with this website, I may click a button and that click trigger an event and it will respond some actions. But when it comes to natural language processing, it will process my words, my speech, and provide me a fair response. Not only that, it can summarize text and everything. So this is natural language processing is kind of an intersection of computer science, artificial intelligence, cognitive science, and linguistic. So there are subdomains in NLP. So you got, this is a drawing. So this is what I mean by processing. So I'm kind of trying to visualize this. So you have natural language. So let's say Obama, or instead of using Obama's example, all right, okay, he's a politician, so here we have Obama giving a speech. So you want to understand what he is saying. So the subdomains will be speech recognition. So you speak, let's say this person speak, and then your machine, this is a machine, let's say this is a tool, this is not just a machine, this is your machine, so let's say machine, and then it will recognize your speech into texts, so it will transfer them into a text. All right, so once understand the English words and the context, it will recognize the speech from text, speech to text. And then the other subdomain is natural language understanding. And then, so this natural language understanding means you got the speech and then the sounds will be changed into text. Then the natural language understanding will, this system of algorithms and this computationally well-trained AI system will understand these speeches, and then it can natural language generation where it can generate a system. So as I put it here, this is a microphone, so which means it indicates someone speaking, so it can recognize speech. And then this is understanding the human thinking, so natural language understanding. And then here, as you can see, this is the AR and it's generating responses, so natural language generation. These three are the subdomains of NLP, so we can look them here, as you can see. So natural language recognition, identify words in spoken language, including speech-to-text processing. Natural language understanding, extract the meaning of word and sentence as well as reading comprehension, and is able to generate a meaningful sentence and text. These are subdomains of NLP. Okay, so let's get return, skip back. Okay, so these are the subdomains. Now the historic development. So, um, as a science, everything takes time. So it's developed through its conception started in 19th century. René Descartes here and Leibniz here. So Leibniz is a theologian. He's invented calculus independently, and according to this resource, I didn't done a lot of research based on the claims. So according to this person, uh, in the 17th century, René Descartes and Leibniz contributed to what we call natural language processing. But later in the 1950s, there was a word division of order, so capitalism and socialism. After World War II, the world get into Cold War, so there was a fight between USSR, an ideological fight between USSR and USA. So there was a need to English Russian translators because there is a saying. Um, Here is a quote. I think this is from a Chinese war leader, Sun Tzu. If you know the enemy and know yourself, you need not fear the result of 100 battles. If you know yourself but not the enemy, for every victory gained you will also suffer a defeat. If you know neither the enemy nor yourself, you will succumb in every battle. So I think this is strategy of war. It was a war. It wasn't a declared war, but it was an ideological war. So there was a lot of things going on. So there was a need to English translation. English to Russian translation. So this was the root cause in 1950s. Then in 1964, everything was abandoned. But during this time, the Martians were kind of rule-based, so they built them based on rules. All right, we can check it here as well. All right, this is the development kind of this sentence explained well, then complex than originally anticipated, then you know what there. So like there was the first result promising, so they kind of wanna translate do this job, so they hire people, and then there were not enough people, so they try to build a machine that translates Russians into English. So the first thought that can come into your mind would be, hey, why don't we translate grammar by grammar? So, but language is not only about grammar. There is syntax, there is semantics. So that machine can produce the intentions or everything. Just it can only be translated like to somewhere things or like that. So this was a total failure. At first it was promising, so they spent like 13 or 20 years, 16 or 20 years on it, and then they abandoned it. So like in 1964, enough is enough. They abandoned it, which means NLP hopelessness started, and whenever there is a hopelessness intake, oh, it's a winter time because winter in AI winter times are where funds decrease, expectation become lower. So yeah, NLP natural language processing winter started in 1964, and then there was a committee, automatic language processing advisory committee. These are the committees. They decided enough is enough. We no longer pursue this dream. And then, if we go back to in 1964, what things were happening in US. So there was IBM released 360 family. IBM released a machine, and Big Bang was verified that year, and picture phones were kind of invented that year. So a lot of things were going on. So the investor meeting, whoa, this is not showing progress, so let's change. So they abandoned the project, and then this is hopeless person and AI hopelessness. It shows AI hopelessness. This one cry AI winter. As you can see, there's rain, and yeah. So we can also refer here. So as I told you, attempted to outsource translation to machines. So no significant could be. Then it became hopeless. So after 20 years, NLP began, LM started regain interests. So they make it in 1964, and then, which means if it starts like in 1950s, it would be in 1970s. So 1972 or something started interest. Started gaining interest because if you see where this at this times SQL was invented at this moment, at the first SQL. So SQL first invented. I don't know, man. This is your so you know what I mean. IBM was like doing a lot of works, but I so SQL was invented this year. So a lot of invention were going on. So you can store data because for any kind of AI work, you need three things. The first is algorithm, the second is computing power, the third is a lot of data. So in SQL, so they can store, they had the algorithms like from Turing tests. So I think they didn't have the power, but they were the computational power, but they billion. So in 20 years, so they kind of return back and more slow. So because of three factors, the first was increasing power of computing, increasing of computing power. So there is a more slow. More slow is in every 2 years, the number of transistor and the cost are kind of reversed. So as the number of transistor increase, the cost will go down. So in 2 years, in every 2 years, a transistor on integrated circuit will double every 2 years with minimal rising cost. So it will rise in cost, but it will be minimal. So this is more slow. So increasing power of computing power, as I told you, IBM released this IBM research. So I can research IBM's achievement during between 1950s to 1970s, like let's say 75, or let's be generous till like 80s. A lot of computer like a lot of before 1970s achievements like so before 1970s they got artificial, you know what I mean, including this a milestone in computational technologies. They got Fortran, IBM's 74 Fortran programming language, Cyber Airlines. So they got all of this. So it was a hope. All right. The first one is increasing computing power, as I told you. The second one is shifting paradigms. All right. So you can't teach an old dog new tricks. This is my quotes. it may not be related with, but the paradigm is, as I told you previously, it was complex rule-based systems, like grammar by grammar, word by word. So they changed it into statistical and decision theory foundations such as decision trees. So they changed the NLP methods into this. So kind of the paradigm shift. So the first one is computing power, the second is shift in paradigms. And what was the third one? The third one was part of speech tagging. Okay, this is the third one, part of speech tagging. All right, part of speech tagging. Okay, so for this technique, split into smaller units, like individual sentence, words of words using phrase tagging, grammatical function categorically are added to a given text. This allows to describe a speech using Markov loops. So Markov principles, we will return them later, like in reinforcement learning. There is a Markov law. Here, Markov law is kind of a way of predicting the prediction. So you study the past to predict the next. So you only care about the first and the third, the next. So it's used literally in reinforcement learning. We will talk about that as well here, but we can talk about it like why don't we? So bear with me. I'll return back. I will return back. So bear with me. I'll be back. All right, so we're back. Let's return to our studies. And then, okay, so what is this? To emulate, to able to value different paths in Librens. Librens is kind of a way we need to suitable approach to as this. Okay, what is this? This is okay. Okay, if the person sorry, be back. Alright, so when task in a reinforcement learning satisfies Markov property can be more or less a modified process. So this is Markov laws. Markov properties probability of future event based on a sequence of possible events. So if a present state holds all relevant information about the past actions, it is said to have a Markov property. In reinforcement learning, the Markov property is critical because all decisions and values are function of the present state. So decisions are made depending on the environment's state. So that's as how they transition. So part of speech tagging, so you chunk the words into simple, like for example, you have a paragraph, and then for example, they say, whoa, we can look into this, but you have like, for example,